Here we're looking at section 3.3 and completing the square. So our big essential question is, how can you complete the square for a quadratic expression? And we'll see why this becomes very useful here at the end of today. So first, our learning targets. First, we're going to solve quadratic equations using square roots. And we've done this in our previous lesson, but now we're going to look at it a little bit differently. Then our second is to solve quadratic equations by completing the square. And the reason we do this is really this third learning target, is so I can write these quadratic functions in vertex form and be able to quickly and easily find my vertex. So my first example, solve x squared minus 16x plus 64 equals 100 using square roots. So generally I wouldn't say this would be a square root one because I have this x term. But I also notice that my left side is an expression, a quadratic expression, that can be written with square roots. So I know that x squared minus 16x plus 64 can also be written as here this quantity is x minus 8 squared. Well, so now that I've written it this way, I can go ahead and take the square root of both sides. So I end up with x minus 8 equals plus or minus 10, because remember, anytime I take the square root, I have this plus or minus, and then I solve. I just add 8 to both sides, and I can follow my math and go from there. So I can factor this trinomial into a binomial squared. Not all quadratic expressions can be done that way, but these ones can, so try these. Okay, so now we're going to look at completing the square. So here's kind of what a picture of what it looks like. So I'm completing the square for this expression, my x squared plus bx. So in order to complete the square, I have to divide b by 2 and then square it. So here's what I'm looking at. So I've got x plus b, I've got bx right here, and my x here. So I've got x squared plus bx. So I want to break this b value in half so I can make an actual square, and then this would be b divided by 2 squared. That's kind of a picture of what it looks like, and we'll continue to look at some of these as we go. So here's what it looks like in algebra. So we're going to actually just break a couple of these examples down. I think that's easier. So first we have to find the value of c, so my c value that makes this a perfect square trinomial. Then write the expression as a square of a binomial. So in order to do that, I have to start it in my standard form, so x squared plus bx plus c. So I take half of my b term, so I take this 14 and divide it by 2 and get 7, and then I square that and I get 49. So that will be my value of c. That's where that goes in right here. So now I can rewrite this as my square of a binomial. So you'll notice here I've got my x plus 7 squared. So you'll see that this value that we come up with here is what goes in here. So this will come into play a lot here in just a few minutes. Okay, so here's some for you to try. Try and figure out if you can figure out what this c value is going to be in order to make this a perfect square trinomial. Okay. So now here we're solving by completing the square. So the first thing I want to do when solving by completing the square is get everything, all my constants, to one side. So now I have x squared minus 10x equals a negative 7. So now I have to figure out what can I add to both sides to make this a perfect square trinomial. So again, I've got my x squared minus 10x plus some value equals negative 7 plus some value. So when I add it to the left side, I have to add it to the right side. In order to figure that out, I take this value and divide by 2. So now I have a negative 5 because negative 10 divided by, so here we're going to divide by 2. And then to figure out what this goes is I take this value and I square it. So this becomes 25. So then this also has to become 25. Okay, so now I have x squared minus 10x plus 25 equals a negative 7 plus 25. Well, so now let's do our next step. This side I want to write as my binomial, and I can simplify it. Negative 7 and 25 gives me 18. Okay. So now over here I see the value that has to go in here is going to be this negative 5, and that I get from right here. So now I have x minus 5 squared. So I want to take the square root of both sides. So I have x minus 5 equals plus or minus, whenever I take the square root of something I have plus or minus 18, and now I'm going to add 5 to both sides. So I have 5 plus or minus the square root of 18. Well, let's go ahead and simplify this radical so we can have the best answer possible. So I'm going to break this down, 9 times 2, and I know that 9 is 3 times 3. So since I have these 3's, I'm going to have 5 plus or minus 3 times the square root of 2. And this will be my final solution because I still have my 2 answers here. So I can use completing the square to solve these as well. Okay, so now let's look at this one. This one's a little more complicated because my a value is not 1. Right? In my last one, my a was 1. That is the first step when completing the square, is I have to get this a value equal to 1. So that's my first step here. So I divide every single thing by 3. And I rewrite that new equation. So now I have x squared plus 4x plus 5 equals 0. So then again, I get my constant over to the other side. So I have only things with my x. Now I have to figure out, what do I add to both sides? So I take my middle term, my b term, and divide it by 2 and square it, which gives me this 4. Divide by 2 and square it, which gives me these 4. And then I can write this as my binomial squared. And remember, I get this 2 by dividing this b term in half. And I simplify my right side. So then I can just simplify, take the square root. I see here I'm taking the square root of a negative, so I end up with my I value, my imaginary number that we talked about in our last lesson. Okay? So I can just continue to simplify until I get my 2 final answers. So I end up with negative 2 plus I and negative 2 minus I. So again, when completing the square and solving, this a value has to be 1 in order to complete the square. If it's not, I have to divide everything by that term first. Okay? So now here are some for you to try. I really want you to look at some of these more complicated ones, like 9 and 10. Try and see if you can do the same thing with these as well. Okay? So now we have a function that we are asked to write in vertex form and then identify the vertex. Well, there's several ways to do this, and the easiest one is by completing the square. Okay? So I'm going to go ahead and write my function. And then I'm going to start by kind of completing the square. So I know I'm going to be using these terms with my x's and adding something to both sides. So I have to leave a space for that I'm adding to both sides. So now I have to find what that thing is going to be. So again, I take my b term, which is this negative 12, divide by 2 and square it. So a negative 12 divided by 2 is negative 6. Square that is 36. So I can go ahead and add my 36 to both sides. Well, so now I need to kind of simplify this piece, right? Because this does not look like vertex form. So I go ahead and write that as my binomial squared. And again, I get this negative 6 by dividing my b term by 2. And now I can kind of simplify one more time. So I want to get y all by itself, so I subtract 36 from both sides. So now here is my final equation. This looks more like vertex form. And remember, I've got a times x minus h squared plus k, and my vertex is that h comma k. So I always want to have x minus here in my parentheses, and I do already, so I know that my vertex is going to be 6 comma negative 18. Okay? So I can do this as well without moving my constant to the other side. This can be done as well. So try these. Make sure that you can get my standard form into vertex form. So now we're often dealing with problems like this when we're looking at quadratics, throwing or dropping or hitting balls. So the height y in feet of a baseball t seconds after it is hit can be modeled by this function. So find the maximum height of the baseball. Ooh, maximum is a word we need to know because that's going to be my vertex. And then I'm asked, how long does it take the ball to hit the ground? So first let's find the vertex. So I want to write this in vertex form. So I write my function. And I know that I'm only really going to be dealing with these 2 values right now. Okay. So we factored out a negative 16 first, just to make our lives a little bit easier. And generally that's where we want to live. Okay. So now I can go ahead and complete the square inside my parentheses by taking my b term, my negative 6, and dividing it by 2 and squaring it, and adding that to both sides. But when I'm adding it to this left-hand side, where I have my y, you'll notice here I have to also multiply it by this negative 16. Since I originally factored out a negative 16 from my 2 terms, I have to include that in my left-hand side. So that's where this negative 16 comes from. It's because I factored. So now I can simplify and write that as my binomial squared, and then get everything over to one side except for y. So now I see I have an a value of negative 16. Which makes sense because if I hit a ball, it's going to go up and then come back down. And I see my vertex. My vertex is going to be at 3, 147.
Okay, so the question I was asked was find the maximum height of the baseball. Well, I know that height is the y value, so this right here would be the maximum height. But I also see that it happened 3 seconds after I hit the ball, which is pretty cool. So then I'm asked, how long does the ball take to hit the ground? Okay, so in order to do that, I want to find the zeros of my function because I want to see where it hits the x-axis again. So I go ahead and substitute in that 0 for my y value, and I subtract 147 from both sides. Since I'm already in vertex form, the easiest way to solve this is using those square roots. So I subtract my 147, I divide both sides by -16, then I can take the square root of that, so I have a plus or minus, and then I add 3 to both sides. Okay, so now using my calculator, I see I have a negative solution here. And this is something I'm not going to care about because I cannot have a negative time. So this solution I just go ahead and get rid of, so I know it's going to be my positive solution. So I see that I hit my maximum height at about 3 seconds, and that maximum height is 140 feet. And the ball hits the ground approximately 6 seconds after I hit it. So I can use all of this information and completing the square to write it in easier forms for me to answer those questions. Okay, so now see if you can do that same thing. Complete the square with this function and see if you can answer those same questions. All right, so looking back at our learning targets, first we solved quadratic equations using square roots, and we've seen now how that can be kind of a simple way to find our zeros and find where the ball hits the ground, those kinds of things. Second thing we did was we solved quadratic equations by completing the square. And then third, and something we're going to be doing often, is writing quadratic functions in vertex form. So it's easiest to go from standard to vertex when I can complete the square. So now that we've gone through all of these, go ahead and start working on your homework for this section.